Hey folks, this is lecture number 2 on arrays, and in today's lecture we're going to cover the .length property, we're going to talk about linear searches, and we are going to talk about finding the minimum and maximum values in an array. So in the last lecture we looked at how you would go about declaring an array, and we looked at how you can access individual cells in an array. Today we're going to do some more stuff with that. So one of the first things we're going to talk about is there's an interesting thing you can do with an array, which is you can ask it how big it is. So we're going to take this example here, and I'm just going to run over to the Replit window, and I'm going to create a character array. So car array, and in this case I called it my new array, is equal to new car. And this one is being initialized with values. And if you're not sure what this is all about, go back and watch the previous video. So I'm creating an array that has values in it. And what I'm typing in here is a bunch of characters. Characters are always going to have single quotes, and each cell is able to hold one character. So effectively, I'm putting an H into the first cell and an A into the second cell, and so on and so forth. And at the end of all this, I put in a semicolon to delineate the end of the line. Okay, so I've created an array, and it has various different values in it. And I could absolutely print out any one of those. So for example, I can print my new array at position 2, and we can see what's in cell 2. And if I get rid of that hello world, you're going to see I'm going to get H is in cell 0, A is in cell 1, that P is in cell 2. So it's actually the P here that got printed, the one that I'm highlighting in flashing orange there. So that's great, but it would be nice to be able to tell how big the array is. One downside of initializing it with values like this is I may not know exactly how many cells are in there. So it'd be nice if I could just ask the array how large it is, and I absolutely can do that. So I can say int size, and you can call this variable whatever you want, I'm just calling it size, is equal to my new array, that's the name of the array, and then I'm going to type .length. And you notice that when I started to type length, my IDE automatically filled in length because it understood what I was trying for. And then I'm just going to print out the length variable, or the size variable, sorry. All right, so when I print this, it's going to still print the P from happy, but then it's also going to print out size is, and it's going to tell me the size. It tells me that this array has 9 cells. So let's look at this. So 1, 2, 3, 4, 5. This one is still there even though it's empty. That's 6, 7, 8, 9. Now, what I want you to remember is, and I've said this before, but I'll say it again, the size of the array is 9, but there are cells 0, 1, 2, 3, 4, 5, 6, 7, 8. There is no cell 9. Even though the size is 9, there is no cell 9. And so very specifically, the reason I keep bringing this up is, let's imagine I then turn around and I try to pull one character out. So char x is equal to my new array at position size, or just to be more specific, at position 9. We know that the size is 9. I'm going to try and run this code, and what's going to happen is it's going to begin to run, and then it is going to give me an exception. It says exception in thread main, Java language array index out of bounds exception, index 9 is out of bounds for length 9. So it knows that the array is 9 cells big, and it knows that I'm asking to access cell 9, and it's saying you can't do that, there is no cell 9. Only cells 0 through 8. So be careful when you're accessing the array, you can never access cell 9. The most common thing is you do something like that, or you do something like this, int I equals 0, I less than or equal to 9, I plus plus. This will cause the exact same problem, system.out.println, and I'm just going to print my array at position I. I'm going to get rid of this one because we know that one is an error, and I'm just going to run this. And so what I'm trying to do is I'm trying to print out, it's my new array, I'm trying to print out each one of the cells in my array one at a time, and this is going to run, it's going to print out cell 0, 1, 2, 3, 4, 5, 6, 7, and 8, and then I'm going to get the crash. So this is the loop running right here where there's the HAPPY day, and then the exception or the crash of the program happens because it tries to access cell 9, and that's because I'm allowing the I to get to 9, but I don't want the I to get to 9, it should stop at 8. So again, I've said this 15 times, but I'll say it again, there are cells 0 through 8 in an array that is 9 long. All right, so the point of all this was the length variable. it is quite common to need to pull out the length of an array. And actually, anytime that you write a for loop, what you would probably want to do is, instead of hard coding the 9 here, you would tend to say, while I is less than my new array dot length. And it is possible to do that. And since I changed this back to a less than instead of a less than or equal to, this will now work correctly. It will print out happy day, and I will no longer get the crash that I was getting before, because it's only accessing cell 0 through 8. This property is 9. We know it's 9 because we printed it out up here, but I less than 9 means I will never get to 9. It will only go up to 8. All right, so the length property in an array tells you how big the array is, and it's really handy to be able to ask an array how large it is so that you can figure things out. As I say, it's very common to use that in a loop. That's pretty much the example that I just did here. And so this gives you an array, a loop that's iterating over each of the cells in the array and then doing something. In this case, I'm just printing out each one of the cells. All right, and this comes to the question of, why would you not just put the 10 in there? If you know the array is 10, why would you ever use dot length? And the answer is because you'll see sometimes you won't know how big the array is. You may be given an array that you don't know how large it is. It's not something we're going to cover in this class, but later on you're going to see that that's going to happen sometimes, where some piece of code hands you an array, but you don't necessarily know how big it is. So you'd probably want to ask the array how big it is and use that in all of your loops rather than hard coding it to 10. Okay, so there are lots of common things that you will want to do with an array. And many of these are things that are asked on tests. They're also very common questions in interviews. If you go to a coding interview, they will ask you to find the highest value in an array, or find the lowest value in an array, find the average of an array, or the sum of an array. You've already seen sum and average. Those are just a loop that was covered in the last video, where you set up a sum variable and then you iterate through all the cells of the array and you add them one at a time to the sum variable until you have an answer at the end. And then we also saw how to do the average, which is just you divide by the length of the array after you've calculated the sum. The other thing that is a common thing that you'll want to do is to see if something is in an array, or to search an array for a value. So let's think about it this way. KSU has an array of all of our KSU IDs, and so there's 40 or 50,000 people in that array. Well, a question may be, is this still a valid student? Is this still an active student? And so they may have a KSU ID number that they want to check, is it anywhere in the array? And so that would be a circumstance where they would need to have a loop that looks through all of the cells in the array and sees if this KSU ID number that they're searching for is actually in there. And so that's a pretty common thing that you'll want to do as well. So we're going to take each of these and we're going to look at them and we're going to figure out how to code them. So finding things in an array. This is a common question to see if an array contains a particular value. And we're going to start off with the same array that we had that has characters. And again, I'm doing it with characters just so that you can see that you can absolutely have arrays of things other than ints. It's a common misconception because most examples you'll see on the internet are arrays of integers. So it's just because it's easy to work with integers, but there's no reason that you can't work with other things. So it just happens to be what most people write examples in, but you can absolutely do them arrays of any type. All right, so I've created that same array, car array. I called it my new array, and it has each of those letters one at a time in cells. So cell 0 has an H, cell 1 has an A, and so on and so forth. All right, so I want to check to see if the array contains the letter D. And this is the thing that I'm searching for. So we'll often call this the target. The target is D. I'm looking for D in the array. And so I'm going to check to see if D is in each of the cells. So the basic algorithm that we're going to follow is called a linear search. It's called linear because we're going to look through the array one cell at a time in a linear fashion. And we're going to check to see if we find the target in any of the cells. So we generally start off in cell 0. We check to see if the value of cell 0 is equal to my target. If it is, great, we have found it and we declare that we have it. If it is not, then we're going to move on to cell 1 and check that cell. And if it's not there, we're going to move on to cell 2 and then cell 3 and cell 4. And so this is a very methodical search. It's kind of like how you look for your keys in the morning. You start in the place that you think you left them, and then you work your way backwards to the least likely places until eventually you realize they're in the freezer. So you start in the first cell, you move your way over, and you keep checking each of the cells. So what kind of loop should we use here? Well, I know how many cells I'm going to have to look at worst case scenario, which is the entire size of the array. So perhaps the right answer is I'm going to start at cell 0 and I'm going to work my way up to cell 9, or in this case, I think it's cell 8 because there are 9 cells in this array. So I'm going to use a for loop because I know how many times I'm going to have to go. Now, the truth is I may stop because if I find the answer in cell number 2, I don't have to keep all the way going to the end. I've already found it. I know that they're in the array. And you might say, on average, you wouldn't have to look in the whole array. As a matter of fact, you're probably going to only ever have to look at half of the array on average, because an average thing that you look for will be somewhere in the middle. But you're going to write the loop as if it's the worst case, which is that it's in the last cell, because that is possible. And then if you happen to find it sooner, we're going to stop the loop because we've already done it. So there's actually going to be 2 ways that this loop may end. One is you've gotten all the way to the end and you didn't find it, and the other is that you have found it, and so there's no reason to continue looking. All right, so we're going to start coding this. So our target that we are looking for, I'm going to declare as a character, and it is D. All right, and so what I want to do is I want to look at each of the cells in the array, and I want to see if they are equal to a D. Of course, I can tell that this is going to be true when I get down to here, but I'm going to write the code to do it because I might be looking for other things, and the array may not be quite as easy to look at on the screen. So I'm going to say for int I equals 0, I less than my new array dot length. And this is using that length property that we just talked about, I++. Okay, so this loop is going to go over the content of the array. And what I need to check is if my new array at position I, which the first time through the loop will be 0, the next time it'll be 1, then it'll be 2, then it'll be 3, is equal to the target. So if I find the target in the cell, then I'm going to print out, found it, and I'm done. If I found it, I can stop the loop. So I'm going to actually type break. And you might remember this from the lecture when we were talking about loops. Break immediately stops the loop. And so even though the for loop would naturally have gone all the way to the end, if I found it, there's really no reason for me to keep looking for it. So I call break in order to stop the loop. All right, and so we're going to run this guy, and not surprisingly, it's going to tell us that it found it. There it is, found it. All right, so it might be useful for it to tell me where it found it. So I'm going to add a little bit more value in here. I'm going to say found it in the cell, and then I'm going to print out the value of I. And we're going to hit run here again. I is the loop variable from this for loop. And as you can see, what it's going to say this time is found it in cell 6. And if we look up here, 0, 1, 2, 3, 4, 5, 6. That makes sense. That is where the first D is. If there were multiple Ds in here, it would find the first one, because that's how this is written. And specifically, if I change the target to P, notice that there are 2 Ps, but it's going to tell me that it's in cell 2, 0, 1, 2, because that's where it found it. And once it found it, the break happens, and so it doesn't look anymore. If I were to take out that break and just run this loop again, you would see it would actually say it found it in cell 2 and also in cell 3, because there are 2 of them in there. And so, depending on what you're trying to do, it may be useful to allow it to tell you if there are duplicates in there. In the case of a KSU ID, if KSU is looking for somebody, we just need to know are they in there or not, so a break would be appropriate. But if you're asking for all the people who are CS majors, then there is going to be more than one, and so you might want it to print out all of the CS majors from an array of majors, in that case, which would probably be strings. Okay, so this is the code for declaring an array, putting some values in it, and then creating a target, and then we used a for loop to go through each one of the cells of the array and look for something. In each case, what we were doing inside the for loop is we were checking to see if the target was in that next cell, and if it is, we said we found it, and otherwise we keep going. So that's the code for searching for something in an array, or as it's called, a linear search. There are other methods to search an array. We're not going to talk about them in this class, but a linear search is the simplest case, and it is also the dumbest case, right? It's going to go and look in every cell one at a time. In the case of random data, which this is pretty random data, HAPPYDAY, there's no order to that, so there's no way that I can really optimize this. But if the values were sorted, there is another algorithm that we could use, which is called a binary search, but that's, again, not something we're going to talk about right now. All right, so this is your code for a linear search. And what we're going to do is we're going to trace this so that you can see how this works. So we're starting at main as always, and we create a target which is equal to D, and then we create an array that has all of the values in it. You can see it's cell 0 through cell 8, and it's called my new array. And then we're going to go into our loop. All right, so this creates an I variable. It's initially set equal to 0, and I is less than the length of the array. Well, the length of this array is 9. When I ask for the length, it's going to tell me 9, even though it's cells 0 through 8. So I, which is 0, is less than 9. That is true. So we're going to go into the loop. All right, it checks if my array at position 0, because I is currently 0, so that's this first cell which has an H in it, is equal to the target, which is a D. Well, that's not true. H is not equal to D. So it's going to skip over the if statement. That gets us to the bottom of the loop, and we're going to go back to the top and increment I. I becomes 1. 1 is still less than 9, so we keep going. This time it's checking if my new array at position 1 is equal to the target. So my new array at position 1 is this A, and is A equal to D? No, it's not. So it's going to skip over that. Bottom of the loop brings us back to the top. I is now 2. So again, it's checking is 2 less than 9? Yes, it is. And so it says if my new array at position 2, which is this P, is equal to the target, it's not. So therefore, it's going to skip over the if statement, back to the bottom of the loop, back to the top of the loop. I becomes 3. 3 is less than 9. So it checks is my new array at position 3 equal to the target. P is not equal to D. So bottom of the loop, back to the top. I is now 4. 4 is less than 9. If my new array at position 4, which is a Y, is equal to the target, Y is not equal to D, so we skip over that. Bottom of the loop, back to the top, I is now 5. 5 is less than 9, so we go into the loop. If my new array at position 5, which is an empty space, or it's actually a space, if space is equal to the D, it's not, so it skips over the loop, or skips over the if statement, bottom of the loop, back up to the top. I is now equal to 6. Okay, so interesting things are going to happen this time. So 6 is less than 9, so we're going to go into the loop. If my new array at position I, which is a D, is equal to the target, which is a D, D is equal to D, so finally the if statement is true. So we're going into the if statement, it prints found it, and then it's going to call break. And as you know, break immediately ends the loop. So it just jumps out of the loop, and it continues on with the next line of code after the loop. The I variable went away because the loop ended, so that's gone. My target is still there, and my array is still there, and my output is still there. Now I'm at the closing curly brace for the end of the program, and the program ends, and all of the variables go away. Okay, so that's how you trace through something where you're walking through an array and doing something. It is very common to do this type of a loop. Very specifically, this for I equals 0, I less than array dot length, I plus plus, is the code you're going to write anytime you're doing something in an array. So I just want you to pretty much memorize that loop because it's something that you're just going to use over and over and over again with arrays. The if statement in here that's checking to see if the array at position I is equal to the target is just because of what we're trying to do here, which is to see if D is in this list. Okay, so this previous code will print out founded if the target is found in the array. But if it's not found in the array, it does nothing. So what I mean by that is if I search for X in the array instead of searching for P or D, well, when the program runs, it just does nothing. The program's going to run, and it's going to end, and I'm going to get no output. And that's not really very intuitive to the user. It would be nice if we could tell the user, no, we didn't find it. And your first guess to fix that might be to add an else here. This is the wrong answer, but you could think, all right, let's just put a print statement in here, didn't find it. And again, this is the wrong answer because every time through the loop, this if statement is going to run. And the nature of an if statement is if this is true, it does this. Otherwise, it's going to do this. And so you get didn't find it, didn't find it, didn't find it, didn't find it, didn't find it. You're actually going to get that one time for each cell of the array. And that's not really what you want. Can you imagine if there was 43,000 cells and somewhere in there it told you that it found it, but for all 42,999 of the other cells, it said didn't find it, didn't find it, didn't find it. That's not particularly useful. So this is not the correct answer. I only wanted to output that one time. So really what I wanted to do is I wanted to print that out only at the end of the loop. Now, as this stands, it's going to seem like it works right now, but it's actually not going to work. So if I run this looking for x, it says didn't find it. And that's great. I seem to have solved the problem. But if I change the target back to a p and I run it, well, now it's going to say found it, didn't find it, which is just a little bit confusing. Because this didn't find it happens no matter what. When I get past the end of the loop, it's just going to happen. And that's not really what I want. I only want this to happen if I didn't find it. So how can I keep track of whether I found it or not? Well, the typical way for doing that is to use a Boolean. So what I'm going to do is I'm going to create a Boolean, and I'm going to call it success. And I'm going to set it equal to false. So right now I have not found it. So success is false. Down inside my loop, if I find it, I'm going to change success to true. Okay, so only if I ever do this if statement will success become true. If I never run this if statement, success will remain false all the way through. And now I'm going to wrap this in a print statement. So I'm going to say if success is true, and then I'm going to put the print statement inside of there. And we're going to cut that, and we're going to paste it here, and there we have it. All right. So let's run it again and let's see what we get this time. So right now it's searching for P, and P is in there, so it's going to tell me that it found it in these two cells. And it should not have printed. Oh yeah, it did find it. Successes. Okay. I wrote that backwards. If success is false is when I want to print it. Oops. All right. Let's run this again. All right, so we're going to run through the loop. It is going to find P, so therefore success is true, so I'm not going to get the didn't find it message. I'm just going to get found it in cell 2, found it in cell 3, and the program ended. Now I'm going to search for X instead, and this is not in the array, so therefore success will never be switched to true, it will always be false. And as a result, at the end, it simply prints out didn't find it because of that. So this is a common tactic to set a variable at the beginning and only change the variable if something good happens, and then at the end you can check, did something good happen? So it's a way of keeping track of whether you succeeded or not as you go through a loop. And again, a pretty common thing. We're going to see something very similar to this in our next example. All right, so that's pretty much the example. As a matter of fact, in this code, you can see what I did was I just used the success variable to print out, yes, I found it, or no, I didn't find it. So instead of doing the print statement inside of the if, I moved it all down to the bottom, and I just used the success Boolean to decide which one I print. And that works the same as what I did in my code. Either one of those is valid. You're just seeing two different solutions to the same thing. Okay, so next up we're going to try and find the smallest value in an array. All right, so the algorithm for this is we're going to assume that whatever value is in the first cell is the smallest. And then we're going to check each subsequent cell and see if they have a value that's smaller. If I ever find one that's smaller, I'm going to remember that that is now the smallest, and when I reach the end of the array, whatever value I have in smallest is going to be the smallest. So I'm going to start a new replit over here, and again, we're going to have an array with some numbers in it. This time I'm going to do an array of floats, and again, I'm just doing that so that you can see some different stuff. So I'm going to grab this line out of the slides just so I'm using the same example. And oops. All right, so I'm going to grab this line here. And what I'm doing in this line is I am creating an array of doubles, and I'm initializing them with some values. So over in my replit window, which is still loading, I'm going to paste in that array up at the top. All right, so this creates for me an array of doubles. And again, there's no rule that says all arrays have to be integers or all arrays have to be characters. They can be whatever you want them to be. So this is an array of doubles. Each cell holds a double. 15.2, 22.5, 7.3, 19.2, and 55.1. It looks like there's 1, 2, 3, 4, 5 cells in this array. Okay, so what I'm going to do is I'm going to create a new variable called smallest. It needs to be a double because I'm looking for the smallest double in an array of doubles, and I'm going to set it equal to whatever is in the first cell of the array, my new array at position 0, which that's going to be 15.2 in this particular array, but this will work no matter what the values are. Then I'm going to use a loop. So for int I equals, and I'm going to start the loop at 1. The reason I'm starting at 1 this time is because we've already assumed that whatever's in cell 0 is the smallest value. So what I'm going to do is I'm going to start at 1, which is the 22.5, and I'm going to see, is it smaller than the 15.2? It's not. So I'm going to move on to the next cell, which is 7.3, and I'm going to see, is 7.3 smaller than 15.2? It is. So then I'm going to remember that the smallest is equal to 7.3. Then I'm going to check if 19.2 is smaller than 7.3. It's not. And I'm going to check if 55.1 is smaller than 7.3. It's not either. And so at the end of this loop, I'm going to know that 7.3 is my smallest value. So I'm starting the loop this time at I equal 1. And that's because, again, I already know that what I've put in I0, or what I've put into smallest, is what was in my new array at position 0. So while I is less than my new array dot length, I++. All right. And so we have our usual for loop. So each time through the for loop, what I'm going to do is I'm going to say, if my new array at position I is less than smallest, then I found a new smallest number. So I'm going to change smallest to my new array at position I. And then at the end of my loop, I'm simply going to print out which one is the smallest. All right, so let's run this. So I would expect it's going to print out smallest is 7.3. And that's because of the values 15.2, 22.5, 7.3, 19.2, and 51.1, 7.3 is the smallest of those. And even if I were to change around these values, this loop will still work and it will still identify which one is the smallest. And it's simply because I assumed this one is the smallest, and then I basically used a loop to prove myself wrong. If the loop got all the way through the loop and nothing had changed to its smallest, that really was the smallest. If any of them were smaller, then I changed smallest to that new value as I was going through the loop. And so I'm just going to make a copy of this array. I'm going to leave the original one in there in case you guys want to play with it, but I'm just going to change it around, and I'm going to put 1 or 1.1 in the first cell, and I'm going to run it again. And notice there's actually now an extra cell in the array, and I don't have to change anything. This is one of the nice things of using the dot length property. It already knows that there's an extra 1 in there because, well, it knows the length of the array. All right, and this one correctly told me that 1.1 is actually the smallest. So again, the way that this worked is it set smallest, which is just a variable, equal to whatever was in the first cell of the array, which in this case was 1.1. And then it used a loop starting at cell 1 and going up through cell, in this case, 6. So there are 6 cells in this array. So while I is less than 6, so 1, 2, 3, 4, and 5 are the cells it's going to look in, it's going to increment I each time through, and it looks to see if cell 1, the first time, is smaller than the smallest. So the smallest was 1.1, cell 1 has a 15.2, 15.2 is not smaller than 1.1, so it skipped over the if statement and went back up to the top of the loop, changed I to 2, and then it went back into the loop and it said, if 22.5 is less than 1.1, which it is not, so it went back up to the top of the loop, changed I to 3, and checked if 7.3 was less than 1.1, it was not, changed I to 4, checked if 19.2 is less than 1.1, it is not, and changed I to 5, and checked if 55.1 is less than 1.1, which it is not. And so at that point, the loop ended because it had reached the end of the numbers. It had gotten where I was now 5, 0, 1, 2, 3, 4, 5, and when it tried to make I into 6, 6 was not less than 6, so the loop ended. And when the loop ended, it printed out the smallest value is smallest, and it printed out my smallest is 1.1. So this is one of the ways in which you can find the smallest value in an array. You make an assumption that whatever's in the first cell is the answer, and then you work your way through the cells to prove yourself wrong. If any of them are wrong, if any of them are smaller, then you replace the smallest with that one new value. All right, and so the code for that is right here on the slides, and that is almost identical to what I wrote. So it defines the array up at the top, and then it creates the smallest and sets it equal to cell 0, and then uses the loop to prove that wrong. There is another way to do it, which is instead of assuming that whatever's in the first cell is the smallest, you can also just assume that the smallest is some really large number. And that really large number will then be proven wrong when it reads the very first cell. So I'm just going to show you this other version of the code. It does the exact same thing as what I did, but instead of setting smallest to the first cell value, I'm setting smallest to something called double.max value. All right, so double.max value will hold the highest possible value that a double can hold. And a double can hold some very large number. So it just knows what the max value is. You can see this is all in caps letters, which tells you it is a constant. And so this is a constant that's built into the language. There's a double.max value, a float.max value, a int.max value, a there's a car.max value, I think, and so on and so forth. So there's each one of the different types followed by .max value. So what's happening here is smallest is set to double.max value, which is some huge number. And then the loop starts at cell 0, and it checks to see is what's in cell 0 smaller than that. Well, it guaranteeably is, because you can't have a number bigger than this, so therefore 15.2 will be the smallest one. So it will change smallest to 15.2 on the first cell, the first iteration of the loop. Then it checks if 22 is smaller than 15, if 7.3 is smaller than 15, which it is, so it remembers 7.3 is now the smallest, and then 19.2 and 55, neither of which are smaller, so it prints out smallest as 7.3. So my point is, this is the other way to do a find minimum value in an array, or find smallest value in an array. These two blocks of code work the same way, they're just two different ways of thinking about it. In this case, the original one, I assume that the first value is the smallest and then work my way through it. In the second one, I assume that the largest possible number it could ever be is the smallest, and then I prove myself wrong as I go through the loop. They both work. The only thing to be careful about is in the original one, you probably want the I variable to start off as 1, because you don't want to check the first cell. It would work if you started 0, but it's extra work that you don't need to do. Whereas in the second one, where you're doing the max value stuff, you absolutely need to start the cell or start the loop at 0, because you must check what's in cell 0. You haven't assumed that cell 0 is the right answer, therefore you must actually you must check cell 0 as you go through. So those are two ways to find the smallest value in an array. Next up, we're going to look at how to find the largest value in an array, which pretty much works the exact same way. The only thing that's going to be different is you're either going to set the largest value equal to the first cell, or you're going to set the largest value to double.min value instead of max value. And so if we take a look at that code, here we have pretty much the same code as before. I create a variable called largest, and in this case I set it to double.min value, which is a really small negative number. And then I create my array, same as before, and I use a loop that starts at I equals 0, and I check for I length, and I do I++. And each time through the loop, I check to see if that particular cell is greater than the original largest. And since this is the smallest possible value that it could be, 15.2 will be larger. So largest, it'll start off as negative some very large number. We'll call it 2.5 billion. It's probably bigger than that. All right, and that's a negative 2.5 billion. So it checks, is 15.2 greater than this number? And it is. So it wipes that out and it changes it to 15.2. All right, and then we move on to I, which was 0, now becomes 1. All right, and that's because of the I++. So again, it's checking if my new array at position 1, which this time is 22.5, is greater than largest. Well, 22.5 is bigger than 15.2, so it's going to set largest to 22.5. All right, I becomes 2 at the top of the loop because of the plus, and now it's checking if 7.3 is greater than 22.5. It's not, so the if statement doesn't happen. I++ again, I becomes 3. All right, and so this time it's checking is 19.2 greater than 22.5. It's not. So back up to the top of the loop, and we're going to do the I++ again. So I is now equal to 4. And this time it's checking is 55.1 greater than 22.5. And of course it is. So it sets largest equal to 55.1. Largest is equal to that cell. So at the end of all of this, largest is equal to 55.1. And so when you print out largest is largest, you get largest is 55.1. This is identical to what we just did with smallest. The only thing that's really different here is that you are checking to see if the thing is larger, and you're using a very small value to start with instead of a very large value. But other than that, it's pretty much the same code as finding the min for finding the max. And so there you have it. That shows you how to find the size of an array, which was just the dot length, the smallest value in an array, which is this code that makes an assumption and then works its way through, the largest value in an array, pretty much the same as smallest, except you're doing greater than. And we also looked at how to do a linear search, which is to check every single cell in an array and look for something in there. And so that's the end of lecture 2 for arrays, and we're going to pick up with lecture 3 in the next video. So I will see you guys then. Take care.